So students who cannot access because of internet problem, then they can see anytime. Okay. No, just go there. Now I am doing. So go. Don't disturb me. Okay. Okay, we can start, or we have to wait for the others. Shall we start?
Wait for the
Okay, tak sir.
We wait for the other sikit.
sikit 5
Boleh,
minutes.
boleh.
Boleh. Okay. So dulu selamat hari raya.
Selamat Hari Raya sir.
Raya sir.
Maaf Zahid dan Batin, and inshallah you will be good with COVID. Tak ada masalah inshallah soon. Terengganu already hijau. Maybe other states also inshallah will be okay. All Malaysia and all over the world inshallah COVID-19 will finish. You make dua and prayer, huh?
InsyaAllah.
Okay.
InsyaAllah.
Inshallah. So last 4 weeks, this is the week number 5. I give you already the main lecture notes. That is all with problems, but now I try to separate. Last week I sent you chapter 1, small one, not the all lecture notes. And this week we will talk about physical with problems. We solve some problems to make you understand. I think polymer students will face some difficulties because they don't have background about chemistry. For you, I think no problem, because last in pollution control, we did some problems similar to what we have or what we will do in this course also. We will elaborate more, but the main idea is in pollution control you already got. Okay. You follow? Salah with me making disturbance. Diam Salah. You listen to me, can you hear or no?
Yes sir,
Can.
hear
Yes,
you.
yes, sir, yes.
Can, Alhamdulillah. Okay. So we go to the already. Okay, we wait second. We talk in general. For mini project, you will select one instrument, analytical instrument, like atomic absorption, UV, infrared, SEM, scanning, electron microscope, any instrument you want, and I will give you what to do. For example, intro, the theory of the instrument, where can be applied, and some remarks on the instrument. So because big mark will go for mini project. Plus also assignment. I already sent you last week one assignment. Have you seen?
Yes, sir.
Yes sir.
Have you seen assignment number 1?
Yes.
All right. So that one you try to be on time. Try to send on time. I already give you deadline. I give you long time, maybe 2 weeks and more. And very easy. It is theory, and you answer from the lecture notes I give to you. Okay.
Okay, sir.
All right. Hopefully you are not sleeping, because this is the first time we do through team. But I made before record in YouTube, and I think you somehow you watch. It is in YouTube. It is also good because you can go anytime. You can listen anytime you have time, free time. If you don't understand, you can repeat many times. Right. So it is, I think, very helpful for you. Okay, let's start because maybe we will be late. We just go for the next slide. Chapter 2 will talk about water quality testing, and as you know, we have physical and chemical and biological. We have unit operation for physical, like what unit operation, like filtration, screening. We call it screening for big size and filtration for small size. And we go next chapter. Chapter 3 will be for chemicals. Chapter 4 will be for biological. This today we'll do physical with solving problems. Next week or next week, inshallah, we'll make chemicals with solving problems, and after that we make biological with solving problems. So you will get very good idea about wastewater engineering in general, and also because you are engineers with problems and solving of some problems, you will understand more. Polymer students, I think they need extra care, and they can ask through WhatsApp, through mail, through direct contact also, no problem. You can phone me anytime, no problem at all. I will answer you. Okay, Polymer, anyone from Polymer? صادق هذا.
Okay. Okay, sir.
فخر الأداء صادق هذا هذا.
So
Maybe difficult. He has no net access. Maybe I will record this. I already record, so he can see later. Okay.
okay, sir.
So this is physical. We go for physical. In unit operation, water quality testing, physical with solving problems. Unit screening. This is one of the unit operation, but in big scale. It is like filtration, but for big size. Like for example, we have some sand, some rocks, some like bottles, drinking bottles, like oil, vegetable oil bottles, plastic bags. All these bags will be screened by screening. Okay, so coarse solids, which may clog the mechanical equipments and pipes, this will be removed by screening. This is one of the unit operation. Next one is we go for flotation. Flotation, we pump air, and this air will take the like plastic bag, very light, will go to the top. And then, for example, like oil, like whatever, all these contaminants will go by flotation, will go to the top, and we make clearing of this through also filtration. And then clean water somehow will go after flotation. We'll go to also another process after this, which is called grit removal. Also screening, but also for small, like for example, sand, ash, eggshell, etc. A diameter less than 0.2 millimeter. Okay. In organic, which is heavy concentration, will not be removed here because bacteria not capable to break down the structure of the compounds in organic. Inorganic cannot be break by biological treatment process. Inorganic means that metals. Huh? Also concentrated hydrocarbons, organic, will not be broken by bacteria, needs to be reduced by dilution or whatever. Okay. So grit usually removed in a long, narrow through called the grit channel and designed to provide a flow through velocity of 0.3 meter per second. Okay. And settling or settled grit can be removed by manual or mechanical. Okay. So this is also another way of, it looks like filtration, but not as a filter. It is for big scale. Clear? Somehow clear?
Clear.
Yes, sir.
Clear, sir.
Okay. After that goes for primary settling. Now we are talking about preliminary and primary treatment. As we mentioned in lecture 1, we have preliminary, we have primary, we have secondary, we have tertiary. Now we are in the first stage, which is preliminary and primary. Okay, it means that physical separation. We are not talking about chemical. Chemical we will talk in the next chapter. Biological we will talk in the next chapter. Okay, primary settling in suspicion. If, for example, if you have suspended solid, and this suspended solid specific gravity greater than H2O water, it means that it will be settled down. If you keep it for a long time, this precipitate. But if these particles have less gravity, less specific gravity than water, it will not be precipitate, it will remain forever. Like maybe Salahuddin last time did experiment, we need to make chemical, we need to put coagulation, and we make mixing. You saw that, I think, video. That will be chemical, because we add chemical and small particles color will gather and then precipitate. Okay. So primary settling will be naturally by gravity. So any particle have specific gravity higher than H2O will precipitate, less than will remain in the sample. Okay. Secondary settling, it means that we make overflow from the primary, and also we will get more clearer water. Okay, like as you see here. So far, okay. I am talking very slow to make you. Mas Hilmi also there. Mas Hilmi, okay, Mas Hilmi, boleh?
Boleh.
Boleh. Kalau ada question you can ask. Any one of you can ask. You can stop me and ask. Okay, we go to calculation. We suspended solid analysis, and that is very, very important for you. Okay, because engineers don't understand talking, they understand problems. Okay, where suspended solid can be found in environmental engineering, solids are measured in drinking water, polluted water, domestic and industrial wastewater, and sludge produced in treatment processes. Okay. Solid classification. This suspended solid, we have 5 categories, not just one, because we will talk about them and how to make calculation for each of them. Now we are not talking about big size. Big size we already removed by screening and by grit and by flotation. Now we are talking about minute particles in the sample. We call it how to call it, suspended solid. This suspended solid usually have 5 different categories. We have total solid. Total solid will be all solid in water sample. We will understand with problems how. Total suspended solid. Okay, what is total suspended solid? And then we have total dissolved solid. What is the difference between both? And then we have volatile solids. And we have fixed solids. I think in pollution control, we talk secret about this. We give one problem, but here we will try to make it more clearer with maybe many problems. Huh? Okay. We go to the procedure, how we measure the total suspended solid. It's very easy. I think you are all familiar with the we call it, this is here flask, and then we put the sample, and then we go for filtration. This is the filter we put here. I think all of you have done this before. And here, this is vacuum here. And after vacuum, we apply vacuum. Clear water will come here. But here, dissolved ion not will go, will stay remain. Suspended solid will be filtered here. And then we go for this filter here. We take to the furnace at 103 or 105. We make drying. So here we remove H2O from suspended solid here. Okay. And then after cooling down, we go for desiccator to remove any moisture, and then we take the weight. Okay. After we take the weight, we go for ignition. Ignition will not be 105, will be from 550 degree to 600 degree. It means high temperature. In this process, we remove something called VOC, or volatile organic hydrocarbons. These volatile organic hydrocarbons cannot be removed at 105 or a drying process. Needs to make ignition. This sometimes 15 minutes, sometimes 30 minutes, depends on the sample, okay? So here we take moisture already removed, we take here organic compound, okay? And then we go here, cooling down and desiccator to remove any moisture, and then we take the balance. See here, difference between weight here and from the filter will be water removed. Here wet and here wet. This is dry, this is wet. Difference between both will be how much H2O removed. Clear?
Yeah.
Between here, ignition and drying will be how much VOC removed. Between balance here and here, how much VOC or hydrocarbons or organic compounds removed. So we have two heating. In the first heating, we remove H2O. In the second, we remove organic compounds or VOCs. Is it clear? If you understand this one, then to solve all problems for physical or for suspended solids will not be any issue, will not be problem for you. Is it clear or no here? Very important. Understand or no?
Understand.
Daniel, understand?
Yes.
Okay. Sulaiman Taada, Sulaiman mana? Sulaiman have a problem with access, huh? Muhammad Ali Ada. Muhammad Ali Ada.
Ada.
Muhammad Ali Ada, yeah. I think most of you there, but tell your friends that I will keep this so they can watch any other time. Huh? And for you also, if you don't understand, if you go back to this, you will understand more, inshallah, no problem. Okay, we go to flow chart. The previous slide made flow chart here. You see this is total solids, and we made here filtration. In the filtration, we have filtrate. This means that water coming from filter. This is suspended solid, remain. This will be wet, okay? So here we have total dissolved solids, okay? And this one we have total suspended solids. After that, we make ignition, okay? We go for fixed solid. And after that, we have here, from here, will be volatile suspended solid. This is the summary of the previous slides. This is, I will skip this one, but what is total solid here? Total solid of the sample is the matter left behind after drying sample of water at 103 to 105. So this will be total solid, okay? The residue remaining upon evaporation, that will be total solid. All matter except water. It means that after drying process, okay? Metal, salt, inorganic salts, organic material, insoluble salts, soluble salts, etc. All this will be in the total solids. See, also organic material will be there. But after ignition, these organic materials will be removed. Okay, understand somehow, Sikit? Total solid, there are two ways that solid material may be classified. We have suspended solids and dissolved solids. Dissolved solids will be like ions, like what last time, calcium ions, magnesium, potassium, all this will be dissolve. Volatile solids, this volatile we talk about VOC or organic compounds, volatile organic compounds. And fixed solid will be what is remain after drying and after ignition, meaning that will be silica, aluminum oxide, all other minerals that cannot be evaporate at 105 and at 600 degree C. Okay. What suspended versus dissolve? Total suspended solids are the part of the sample that may be caught within 0.45 micrometer filter. This I think you did last time. I remember some of you did experiment how to remove suspended solid and how to weight and how to measure. And we have total dissolved solid are the part of the sample that will pass through the filter. In drinking water, mostly dissolve will be in organic salt, dissolve organic, okay? And this dissolved ions will be hardness. In pollution control, if you remember, we calculate hardness based on calcium and magnesium. And calcium and magnesium, as you remember, has two charge, positive charge. This positive charge and negative charge, maybe we'll give one more lecture or special for polymer students because they don't know how to make if it is valence 1, valence 2. So they need to know the periodic table to see the column here, this will be 1, this will be 2, 3. So they understand more, easy for them to recognize. But with problems in chemical, next chapter, I will try to clarify more so that easy for you to follow. Okay, polymer students.
Okay, sir.
This is a filtration apparatus. You are very familiar. We have here funnel. We put in the funnel. This is the filter here, and then we make this will be the filter, and then we make here by vacuum we take, and after that we take this filter and we make drying, and we take crucible usually for ignition. Why we take ignition? Because crucible can stand high temperature, not to be melt at low temperature. Okay. And the difference in weight, we calculate that 5 different elements we talked about before. This is also the same. We have here all categories you see here, but this is the more clarification about how to get total solids from filtration, and after that filter, non-filter, suspended solid, dissolved solids, and then we go so on and so forth like before. This is just extra for clarification. Volatile versus fixed. Total volatile solid is the portion of the sample lost after the sample has been heated to 550 or 600. This is sometimes for 15 minutes and sometimes for 30 minutes. It's both okay. It is an approximation of the organic material present. What is the importance of this organic material in the waste? Maybe this, if we are talking about marine species, you know, when there is organic compounds in the sea bottom sediments, bacteria will be very active, as you know, and consume all oxygen in the water. So nothing left for plankton, for fish. This is why sometimes in the seashore, we see many fish die because of, we call it eutrophication, or we call it red tides, meaning that lack of oxygen in the water because of bacteria consumption. Because if we have phosphate, nitrate, we have hydrocarbons, then bacteria very happy have all kind of food. So try to utilize all the food, at the same time consume all oxygen in water. This we will talk in chemical also about how to calculate theoretical dissolved oxygen required, like what did in pollution control last time. We will elaborate more, but this is very important factor for the quality of the marine, especially sea and rivers. Okay, when we calculate total organic, if it is high, meaning that we cannot dispose to the open environment, we need to clarify. We need to treat before disposal. Okay. We go to calculation. I know you like calculation. That's very, you are very happy now because theory you don't like to memorize. But in the final or in the assignment, you will have also theory. So you need to understand also theory. We go to calculation here. Okay. What is total solid? How we calculate total suspended solid? This will be, usually we use milligram per liter. Usually we use milligram per liter, or as I told you before, 1 milligram per liter will equal 1 part per million, or ppm. If you remember, okay. If you don't remember, we will see how. Okay. What is B? What is A? We'll see later. How to calculate total volatile solids in milligram per liter will be B minus C. And why we multiply here by 1000? To change gram to milligram, because problems usually given in gram. When you weight the sample, you weight in gram. So to change gram to milligram to be part per million, then we need to change from gram to milligram. Okay. How to calculate total fixed solid will be C minus A. Again, we need to change from gram to milligram. And this total sample volume, this usually given in milliliter. So we need to change to liter. If given in liter, then no need to change. Okay. Okay, what is A? What is B? What is C? A, weight of the filtered paper, okay, in gram. B is the weight of the filtered plus residue at 105, meaning after we remove H2O. This is for dry sample, but still contain organic compounds. What is C? Will be at 600 after remove of water and hydrocarbons, or VOCs. Okay. If you understand this one, then all problems of physical will be very, very easy. We see how. What about total suspended solid? Will be weight of the solid, again, multiply by 1000 divided by sample volume. Weight of the solid will be in gram. Of the crucible dish minus weight of crucible, this will give you the weight of the solid. Because usually when you weight, you cannot weight sample alone. You have to weight it with the filter or with the crucible. You cannot separate. If you make separation, you will get error. Faham? So you weight all, and then you take the balance. You take the you weight before you do your experiment. You take the weight of the filter of the or the crucible, and based on that you can find out how much the weight, the real weight of the sample. Here more details how to calculate, how to prove that 1 ppm equal 1 milligram per liter will be in 43 and page 44. You will see this in details. We will go together for that one after this. Total volatile solids will be weight of the volatiles. Okay. How we calculate the volatiles? We said that dry sample after drying minus after ignition will give you the volatile solids, how much remove. Okay. All right. We go to one problem to make you more understandable. Here, problem say that calculate suspended and volatile suspended solid in milligram per liter. Milligram per liter mean 1 part per million. Given the following data, you have sample volume, you have in milli, right? So this you need to change to liter to get part per million. Weight of crucible, you have here in gram. This you change to milligram. Weight of crucible and dry solid, also in gram. You need to change. Weight of crucible and ash, also in gram. So to calculate suspended solid in milligram per liter will be dry solid in gram divided by sample volume and multiply by 1 million. Why 1 million? Because I change here milli to liter, so I need to multiply by 1000. and gram to milligram, I need to multiply by 1000. So together will be 1 million. This, I think you are familiar with the unit change, how to change from one unit to another. You study in elementary principles. But kalau, especially polymer, don't understand, I will explain to you more, inshallah, no problem. Okay? So dry solid will be, we said that, will be crucible and dry solid minus weight of crucible. This will be here. Divided by sample volume will be 25 milli. And this milli I change to liter. So I need to multiply by 1000. Gram, I need to change to milligram. I need to multiply by 1000. Finally, I will get my results here. 128 milligram per liter or 128 part per million. Usually we calculate contaminants, not percentage. We calculate part per million, part per billion, something like that. Because contaminants supposed to be very small amount, but it makes harm on even human health or our nature, in marine, in whatever. So these small amounts give significant influence or impact in many issues. Okay, is it clear here or not clear how to calculate? Any question here? You are sleeping. You are tired, sleep. Nobody.
No, sir. No, sir. We understand.
Some of you sleeping, yeah? Okay. Okay. Here, another problem here. This is the same problem, but we need to calculate volatile suspended solid. How we calculate the volatile suspended solid? We calculate by volatile solids in a gram divided by sample volume. Volatile solids will be 18.1428, this one. Crucible dry solid, okay, minus crucible and ash. This is after ignition, 600 degrees Celsius. Okay, so I will get the value here and divided by sample volume, multiply by 1 million. So I will get here the answer, 104 milligram per liter or part per million. Okay, maybe one example not enough, you need to know more. We go to another exercise. We have another problem. It says calculate suspended and volatile suspended solid in milligram per liter given the following data. We have here weight of crucible. You may see here all in grams. So we need, when we calculate, in milligram, okay? Weight of crucible and ash, and then volume of the sample. We see Machamana, we calculate suspended and volatile suspended solids. Okay? How to calculate suspended and volatile solid? We apply the same formula. Dry solids will be here crucible and dry solid minus weight of crucible only divided by total volume, okay, and then multiply by 1 million. Actually, I explained why 1 million before. Hopefully you can follow, okay, and then you will get here the answer, milligram per liter. Okay, we go again how to calculate volatile suspended solid for the same problem. We take the volatile solids, how much? How to calculate volatile solids will be crucible and dry solids minus crucible and ash, this one. So divided by total volume, multiply by 1 million, and I will get 76 milligram per liter. Okay, this is the second exercise. Hopefully you understand. We go to one more problem, practice problem 3. We have the following data here, the weight of the dish written here in gram, and we have 100 milli of the sample. If sample given in liter, then no need to change. But since it is in milli, then you need to change to liter. Okay? And here, dish and dry solid given, and after ignition at 550 also given. Find total volatile and fixed solid. if you see process will be here, this is the sample, wet sample after filtration. You go here, you make drying. So here remove of water, you will have here dry sample. Here you make ignition, you take all organic compounds here and remain, it's called it like ash. This ash will be mainly silica, alumina, something like that. Huh? How to calculate total solids? Total solid will be dish plus dry solids minus dish, and you will get this amount. But here you see here he used gram, so answer will be gram per milliliter, no change unit. If you want to change, you need to multiply by 1 million, right? So if you multiply by 1 million, you will get 220 milligram per liter. If you want milligram per milli, then you multiply by 1000. You will get 220 10 to the power minus 3. How to calculate fixed solid? Dish plus unburned solid minus dish. So here dish and unburned solid will be here. This is the dish divided by sample volume, and here multiply by 1 million. So you will get 88 milligram per liter. How to calculate total volatile solids? Total volatile solid will be total solids, this 220, minus total fixed solid, 88. So you will get 132 milligram per liter. Any questions so far? Question Ada? No.
No, sir. No.
Maisara
No,
Ada?
sir.
I'm here.
So far, so good.
Tada soalan.
No.
Clear, somehow okay.
Yes.
Okay. Shuhada, are you Shuhada? Ada, you are from polymer, right?
Yes, sir.
So you understand little or no?
Yes, I understand.
Somehow boleh.
Boleh.
You can answer all assignment and all questions.
Inshallah.
Inshallah, okay. There is here another problem also. Oh, sorry. Mana? How to go back? Okay, this one. I have here 25 milli water sample, and I have dish weight is 50 gram. After evaporation, the weight of the dish and sample became 50.02, meaning that I remove here water. How much water? If you can calculate how much? It's very easy, because you have around here 25 gram minus 0.02, so you have 24.098. This will be water, evaporate. Clear? So dry sample will be 50.02, but inside this 0.2, because this is the weight of the filter, 0.2, this will be hydrocarbons and also other solids. Okay, so if I make ignition here, I will get 0.05. So how much VOCs will be 0.02 minus 0.005. You understand? So what I need to estimate the residue in milligram for total solid, volatile solids, and fixed solid of the water sample. Okay, the process is here to make you understand. So we go for the first one, determination of the residue. How to calculate the residue will be, this is filter plus water after drying minus filter only. So I will get 0.02 gram. Okay. Or if I want to change this gram, as I told you, better to use milligram, I need to multiply by 1000. So 0.02 multiplied by 1000 will be 20 milligram. Okay. If I want to determine the concentration of total solid, how I make it? I divide this by total volume. So 20 divided by 25 milli. And as I told you, I need to change this one to liter. So I will get 800 milligram per liter. Okay. We go to next one. How to determine the concentration of the volatile solids, or VS, will be weight of solid after evaporation minus weight of solid after ignition. So here will be 50.02 minus 50.005. So you will get 0.015 gram. And if I want to calculate this one in milligram, I need to multiply by 1000 here to get 15 milligram. If I want to calculate the concentration, this 15 divided by total volume multiplied by 1 million, I will get 600 milligram. If I want to calculate the fixed solid, then will be total solid minus volatile solids, 800 in the previous one, 800 I show you, mana, 800 here, this one 800, 800 this one, minus 200, I will get 800 minus 600, this one will be 200 milligram per liter. So if you memorize the formula for assignment, no need to memorize, just understand. You have filtration. The filter contain wet sample. You make drying, you remove H2O. You make ignition, you remove organic compounds. What is left? We left only ash. Okay, hopefully you understand. Volatile solid in wastewater. If wastewater, especially industrial, contains volatile solid in the organic portion, short chain fatty acid, ketones, aldehydes, lost during evaporation, solids measurement doesn't give idea about organic content, because this will be volatile solid in organic, like lost during evaporation. So what solids measurement does not give idea about organic contents. You don't know what kind of organic. Is it, for example, benzene, aldehyde, ketones? It gives you there is organic, but you don't know what kind of organic materials. If you want to know what type of organic materials, you need to make analysis. Maybe use HPLC, maybe use UV. If you are talking about, for example, heavy metals, you need to talk about or to use atomic absorption. Organic also, you know, for polymer use also infrared. They use infrared for organic compounds. And if you have standards, you can make comparison, and you get the standards comparison, you get the exact values of the hydrocarbons. Okay, but this, when we make this process, evaporation only at 600, what organic compounds evaporates, you cannot estimate what kind. You know the total, there is organic compounds, but what types, you cannot understand what types. You need to make further analysis. Okay, clear? How to calculate percentage of total solids? I take weight of dry samples divided by weight of wet solids. Here, because I am talking about percentage, if here gram and here gram multiplied by 100, then no problem, because I am not talk about concentration. If concentration, I talk about milligram per liter. But here percentage, so could be gram per gram, pound per pound, kilogram per kilogram, whatever, because this will cancel. So I have only ratio. Hopefully you understand. We see how much amount we can solve. Okay, I will skip this one. We go to problem. Huh? I have here calculate the percent total solid and percent volatile solid of a sludge sample given the following that data or data. You call data. We sometimes use data. Weight of the dish given in gram. Weight of dish and wet sludge given here in gram. Dish and dry sludge given here also. Dish and ash also given. So here, weight of dry solids, how much? I can calculate from weight of dish and dry sludge minus weight of dish divided by weight of sludge or wet sludge. So will be 1995, this one here, dish and wet sludge, minus also weight of the dish. And if it is in gram and gram, tada mas'ala, because here units will be cancelled, and multiply by 100. So I will get the value here, finally 4%. Okay. If I go to volatile solids also, weight of volatile solids will be the same. I follow the equation and multiply by 100, and finally I will get 52%. Okay. Here also another problem, how to calculate the percent total solids and percent volatile solids of sludge sampling given the following data. Here I will not read because already here data. We go to solution. Here total solids will be weight of dry solids divided by weight of wet sludge multiplied by 100. Similar here, 109.46, this one dry sludge, minus weight of the dish divided by dish and wet sludge, minus also weight of the dish multiplied by 100. I will get 3.6%. If I want to calculate volatile solids, also the same way I did in the previous example, you can calculate. Can you do it or tabule? Bole tabule. Bole la. Inshallah bole. Okay, here application of solid analysis in environmental engineering. In drinking water, we are talking about total dissolved solids, meaning that we are talking about mineral. So mineral here is very important for our bodies. If you drink distilled water, is not good. So we have to get some minerals. But mineral also, you need to be in the range. For example, if I are talking about iron should be within the range. If more than this is not good, if less also not good. So we have to take this, there is WHO standards, Malaysian standards, so we have to follow. And drinking water usually contain positive and negative ions, as you see, as you know before, we study in pollution control. And this, if you buy one bottle mineral from market, and you buy minimum or drinking water, you will see that the sweetness of drinking water is better than mineral water. Why? Because mineral water contains some mineral they add, and the cost of mineral water little bit higher than drinking water, because they need to calculate the minerals needed, and they add the suitable amount of mineral that needed for our bodies. Therefore, the cost will be a little bit high. In drinking water, we try to remove all contaminants, viruses, bacteria, and most of minerals. We don't, drinking water doesn't contain all minerals that we need. This is why very cheap. And in the market, you see if you go in the street, there is also reverse osmosis, RO. That also gives you somehow clear water, but not rich with minerals. Am I right or wrong? Natural water here contain these total dissolved solids and TSS. If you take about municipal wastewater, contain total suspended solid and volatile suspended solid. If you talk about industrial wastewater, it contains all, depends on the industry. Okay, and if you're talking about sludge, we are talking about total solid and volatile solids. Usually, volatile solids will be organic compounds. I will prove you that 1 part per million equal 1 milligram per liter. For example, if I have 1 milligram of contaminants in 1 million milligram pure water, this means 1 ppm. So part per million means 1 milligram of contaminants in 1 million milligram of the solution, if it is water or whatever, that will be 1 ppm. Or maybe we can go for, if I assume it is pure water, as you know, density equal 1 kilogram for 1 liter density of water, or 1000 kilogram per 1 meter cube. I think you know this. So if I weight 1 liter, it will give me exactly, if it is pure water, it will give me 1 kg. Okay or not okay? If I weight 1 milli of water, it will give me 1 gram exactly. Okay. So how to prove I want to change this milligram per liter? I want to make this milligram divided by 1 million milligram. That will be 1 ppm. How to change this liter to milligram? First of all, I will assume it is clean water. So 1 liter will equal 1 kilogram. Is it right or wrong? Now I change kilogram to 1000 gram. My target is to make milligram. After that, I will change 1 gram to milligram, 1000 milligram. Okay. Now milligram, this I need this milligram with this milligram. This will go. So finally, what I will get? I will get here, as you see here, 1 milligram divided by 1 million milligram. Okay. So here, this liter will cancel with liter, kilogram will cancel with kilogram, gram will cancel with gram. What I will get here, milligram, here 10 to the power 3 multiplied by 10 to the power 3, I will get 10 to the power 6. So 1 milligram divided by 1 million milligram, meaning that 1 ppm. Okay, is it clear or no? Faham, tafaham, you are sleeping, wake up.
Faham sir, faham.
Faham, sir.
Faham, sir.
Okay, so with this we come to the end. Hopefully you understand, and I think it is boring, it is not face to face, but this is the only way we have to conduct our classes. And I think for you, you have more time to study at home. Try to utilize time in very good way. Try to do your assignment on time. Try to ask if you have any question, because we are free. We need you to ask. We don't have anything to do. We are waiting for you to ask. Okay.
Okay.
Any questions so far for today?
No sir.
Maybe
No,
chapter
sir.
one. Chapter one, I send you by WhatsApp. Wait. I just I want to clarify. Okay, Hanif. Yeah, Hanif. Hanif, your question about. I cannot hear you, Hanif. What you are saying? The sound?
Hello?
Yeah. Hello, who want to ask? Any question? No one. What you write here? Okay. Muhammad Hanif. Line slow share. It is okay, no problem. Tada masala. I understand. I will keep this recording video for you so that you can refer anytime and study anytime. No problem, okay? But I want, if you have any question now, you can ask. No problem. Sadiq, you understand Sikit or no? Okay, okay, let's talk about lecture notes I gave to you at the beginning. I give you the big one, that one with problems. So you don't have to worry about the problems. Study only the theory. Lecture note I send you before 1 week or 2 weeks. That is chapter 1. That is intro. And today is about physical. Next week will be about chemical. Next week will be about biological. So inshallah, after 3 weeks, 4 weeks, we will finish our subject, and you will need to do your mini project. Okay. Okay, we come to end of for today's presentation. Hopefully you got some knowledge, and inshallah, if you have any question, you can ask me anytime. Assalamu alaikum wa rahmatullah.
Waalaikumsalam.
Thank you, sir.
Thank you, sir.